Hello guys, I'm Kelvin Kipsong and I'm an analyst and statistician, and today I'm taking you through my first machine learning project, and it's simply called Simple Linear Regression. This is the first project of machine learning, and it's actually the foundation of the machine learning. Simple linear regression is the type of regression whereby it has one independent variable and one dependent variable. So I will first run this code so that you can see my name and my title. So let's first start so that this packet for this code this first code to work we must or we should fill these Python packages. I've been doing data analysis with some other software such as Microsoft Excel, SPSS, Stata, and I'm also proficient in some other languages such as SQL, C, C++, and other statistical computing languages such as R, and this one Python, visualization tool, Power BI, W, Excel, dashboard, and now we are in Python. So I'm going to take you through this, my first project of machine learning, and it's called Simple Linear Regression. Let's start. So first, we'll import these packages. So it's import pandas SPD. The next one is import numpy snp. The next one is import matplots, the pyplot splt. This one is already filled cns. This one is plotclear and this is px. And this is we are dealing with a linear regression, so we just put linear regression. The next one we just write this for split partitioning the dataset, train underscore test underscore split. And the other one, these are for evaluation, and the first one is mean underscore squared, mean underscore squared. There's a T for problem here, squared error, squared error. The next one is main underscore absolute underscore error, and the last one is R2 and this for R squared underscore, and this one Statsmodels API SM, and this the last one is import Statsmodels. It will be SMF. So we can press Control Shift to run. Control Shift. Don't know why it's hesitating. Control Shift. There's a line with an error. Let's see which one is this one. Mean underscore squared underscore error. Yeah, you should put here underscore. Yeah, so it's let's wait. Yeah, it's running. So if we run this code, then it will run. So just as I've said, my name is Kelvin Kipsong, the statistician and analyst, and I'm taking you through my first project, project 1, machine learning with Python, and it's called Simple Linear Regression. Now let's start. Python has two packages which deal with machine learning, and the first one is Sklearn package, and the second one is Statsmodels. So we will use this method to perform a simple linear regression. The dataset that I will use, you can access it from this link. And if I open my Excel here down, you can see the dataset. It has 4, 1, 2, 3, 4, 5. It has 5 rows, but the important one are 4. But in this case, we will use these cells as dependent variable and DV as dependent variable. This is a lot of dataset, and we will transform it so that we can use it. That's 200 rows. Let's go back there to my browser here. Yeah, now we're here. So just as I've said, it has 200 rows and 5 columns, but 3 are important. But since we are dealing with a simple linear regression with one dependent variable and one independent variable, then we will use cells as dependent variable and the TV number of TV advertisement as the independent variable or explanatory variable, which it will explain the predictor cells variable. Okay, now let's start. Here we have already imported some important packages and we can start. Pandas is for data analysis, NumPy is for numerics, Matplotlib is for visualization, Seaborn visualization, Plotly visualization. Then Sklearn packages is for machine learning. And the first one is for, we're dealing with linear regression. The second one is for splitting the data set such that maybe a certain proportion will be a test set, and the remaining will be for training set. This one is for evaluating the model. Should write here model evaluation. Yeah. And the last one is an alternative way, which I've just said we will use the two method, Statsmodels.api and Statsmodel.formula.api. Okay, now let's start. We're starting with Sklearn package. First of all, we will create a function that will clean our data, will import our data, and transform it into a format that is will be processed for the final outputs. Okay, now we will use argument. We will use argument path, which is the path of our data. Then this is how we will read our data, and our file name will be advertising. Add file name advertising.csv. Then I think it's okay. We've just added then shift enter to run. Then it has run successful. So we have imported here we have imported our data. Then we have dropped other 3 columns. Remember it was 5 columns. But then this is a simple linear regression and we are dealing only with number of TV advertisements and cells. Cells is a target or dependent variable, and number of TVs is the explanatory variable or independent variable. So we are predicting the cells based on the number of TV advertising. That's why we have to drop the rest of the columns and remain with 2 only. So we will reach our data frame will be returned with only 2 columns. Since we have imported our data sets, then we have deleted others. This has run successful. Then here next we will print a sample of our data. Then here we'll find the shape, number of rows, and size. Then Shift Enter to run the code, and it's having an error. Let's see what's wrong. No file name. Yeah, it is having an error. The typo error. I misspelled this one. Advertising. Yeah, from the function. Then Shift Enter again. Yeah. Now this is the input that we expected. So TV is the number of TV can determine whether we will have lots of cells or few cells. Now this format of our data and it's in right inputs, and from this formula def.shape we have 2 rows and 2 columns. That's the way we expected. Next, now we want to extract the input and output. We want to slice it. So input, we just name it input is equals to, we equate to cells. No, input known. Input is TV. Then here, then we copy this one, we paste here, and target equals to cells. Then we copy the first parts, then we paste here. Then we press Control Shift Enter. Then we run the code successful. Now this is where these very important parts, and these are the right inputs for the model, linear regression model actually. Now we have extract our input and output. Now it's time to visualize how our data look like. Remember the assumptions of linear regression. It should be linearity. There are some other assumptions such as normality, linear regression, homoscedasticity, and the other. We will look at those next time. Now we are here. Let's visualize this data to test whether it's linear and the type of whether it's positive correlation or negative correlation, the direction. Now we will use plt.scatter, then shift enter to run, and here we are having a graph. Can minimize it. And here we can see sales versus TV, number of advertising of TV. You can see it's linear in nature. This assumption is satisfied. Then let's go to finding the correlation between the cells and number of advertising. We simply use a formula called CORE, CORR, ef.core, then shift enter, and you can see the correlation between TV and cells